Want to learn how science actually works? It's not about memorizing textbooks. It's an active process of discovery. True scientific learning relies on 5 core pillars: observation, testing, surveys, project work, and building models. You can do this in a lab or out in nature. But when you step inside a school lab, safety comes first. Random work without safety rules causes serious accidents and ruins results. Before starting any experiment, you must follow these absolute rules. Never handle lab materials haphazardly. Always wear protective masks, gloves, and an apron. Know the location of the emergency exit. Wash hands thoroughly with soap and water after practical work. Strictly no eating or drinking in the laboratory. Never taste or directly smell any chemical. No playing or teasing your friends. Follow the exact prescribed experimental method. Take special care with burners and never place hot equipment directly onto lab tables. Our greatest tool is observation, experiencing objects or events carefully using our 5 sense organs, or tools like hand lenses and microscopes. For example, looking closely at a flower reveals its 4 main parts: the calyx, corolla, androecium, and gynoecium. We see this in Activity 1.1. Observing fungi. If you leave moist bread covered for a few days, fungus grows. Under a microscope with methylene blue stain, you will clearly see 3 things: root-like structures called mycelia, stem-like structures called hyphae ball-like structures at the tips called sporangia, which contain spores. Crucial clue point: fungi completely lack green pigment. They have no chlorophyll. When observation isn't enough, we make an educated guess. An inference made before testing is called a hypothesis. To prove it true or false, we run a test in Activity 1.3. We test substances using chemical indicators. Lemon juice turns blue. Litmus paper red implies it's an acid. Soap water turns red litmus paper blue implies it's a base. Salt water causes no change in either paper. Neutral true research work starts with curiosity, requires patience, and follows 7 strict phases: goal setting, making a hypothesis, choosing a data method, preparing materials, data collection, data analysis, and drawing a conclusion. Let's apply this to water pollution. When farmers use excess chemical fertilizers, rainwater washes those nutrients into lakes and ponds. This causes an algal bloom, an out-of-control overgrowth of algae. The algae multiply rapidly and consume the dissolved oxygen in the water. Without oxygen, fish and aquatic animals face a deficiency and literally suffocate. You can test this factor in the lab by comparing algae growth in a control bottle, a fertilizer bottle, and an acidic vinegar bottle over 15 to 20 days. Science is a practical manual for reading the world around us. If this quick breakdown helped you master Chapter 1, hit that like button, subscribe for the rest of our science series, and leave a comment below. Stay curious, and see you next time.